Hi, welcome everyone. I'd like to thank everyone for their encouraging words from the last session, and so I've been able to put together this second session. I'd like to welcome Dave Griffin, who's ever faithful admin support, who's looking at all your questions, and he'll be talking to you throughout the time. What we're going to talk about this session is the basic setting up of the electronics to be used from a beginner's point. And also we've got a special guest, John Greenfield. John Greenfield doesn't need any introduction to those of you who know him, but those of you who don't, he's an aero modeler extraordinaire. He builds some fantastic models and pilots some fantastic models. He's been building mainly half-scale aircraft, and if there's anything less than half scale, it's usually classed as an indoor model for him. He's been a great advocate for GPS since its inception. He flew in the second World Masters and managed to come second against the odds of faulty equipment from memory, wasn't it, John? Yeah.
Early days.
Yeah, early days. It was early days, and that's, I think, has inspired Andre to do what he's doing now, actually. So, and he's just an all-round good guy. We've been fortunate enough to have him over here in Australia a couple of times, and I've been lucky enough to have him stay with me, and certainly showed me a thing or two with GPS. It's really good to have you. Thanks, John.
Thank you, John.
No worries.
Welcome everybody who's not seeing this live. We had a few technical problems. But hopefully it's all sorted out now. So if you're watching this not live at some time in the future, a very, very quick recap. We're talking this morning about flying the course and the basics of flying the course. My name's John Greenfield. I'm from the UK. Here is a guest of John Copeland, who is hosting this session. So as I said before, the flight direction is always flown anti-clockwise. And the first thing we were talking about is the turn sector and how to go round the turn. Now, the word round the turn, this isn't pylon racing, so you haven't got to come in one side, round the turn and out the other. You can bag the turn or score the turn or whatever you want to call it, as long as the plane gets into that green area that you can see on the screen. And you can enter that green area from anywhere and exit it from anywhere. So you don't have to come in from the bottom of the screen into the green area, go round the apex of the triangle, which is in blue, and out through the other green line. You can come in and cross the same green line to bag the turn. Now that's quite important because if you're thermaling on the course, and we'll talk much more about that later on, you don't necessarily want to backtrack. You could just hop out the thermal, nip into the turn sector, score the turn, and then carry on. So when you're flying this course, regardless of what sort of GPS gear you're using, there's additional information that's being fed to your ear and screen. And the first one is information about where you are on the course relative to the course line, which is the blue line. And with something like the T3000, you've got an inside and an outside call with the Snipe Raven Albatross setups. You've got a similar sort of thing. And I think Flymate does basically the same, although personally I've never used it. But as you cross the start line, remembering that you've got limitations on speed and height, depending which class you're flying in, the first thing to realise is where you're actually heading. Now, it sounds very simple just to fly around a triangular course, but this triangular course, of course, is virtual. There's no markers on the ground anywhere telling you where to go. So the first and most important thing once you cross the start line is to listen to the audio. And the audio should tell you basically if you're heading in the right direction. If you can imagine a set of parallel lines, parallel to the blue baseline, the bottom line on the screen, set out at nominal 20-meter offsets. As you cross any of those offsets, the audio of your GPS equipment will tell you. So if you hear 20 outside, that means you're nominally 20 metres outside the course. If you then hear 40 outside and then 60 outside, clearly you're moving off the course line. So you need to correct to the left. If you hear 20 outside, then 0 outside, 20 inside, 40 inside, etc., etc., it means you're travelling into the course and need to turn right. Now, this is where it starts to get a little bit complicated, because if you're really concentrating hard on flying the glider, you may forget to listen to the audio, or it might be drowned out by background noise or whatever else. So the first and one of the most important things whilst learning to fly GPS is to ensure that you can concentrate not only on flying your model, but also listen to the audio. And this takes quite a bit of practice. And for that reason, you also may not be fully comfortable with flying up at the fairly high start heights that most of the classes require. So I always tend to teach people at the beginning to say, fly up to some sort of comfortable height, something 200, 250 metres. So the plane's nice and visible. You've got no concerns about losing sight of it or getting too far away. But then just try and fly to turn point 1, cross the start line and fly listening to the audio just to turn point 1. And the important thing here is to really concentrate on what the audio is telling you. Thinking, am I moving into the course or out of the course, or am I flying in a straight line? If you're flying in a straight line, the audio won't actually tell you anything. It only triggers as you cross, actually depending slightly how you've got it set up, but normally these 20-metre offsets. So if you hear 20 outside, but then don't hear anything, you're running somewhere around the 20-metre line. You'll only hear it if you hear 0 outside or 40 outside. Hopefully that's fairly clear. So I'm suggesting go up to nominally 200, 250 metres and just fly out to turn point 1. As you approach turn point 1, you will start to get more information. On the T3000, it's a bunch of beeps. On the Snipe Raven Albatross, it's actually...
no, it's a few beeps on there too, I think.
Yeah, different beeps though.
Yeah.
With the T3000, you've got a beep at 100 metres from the turn point, a double beep at 50 metres, a triple beep at 20 metres, and then it basically goes ding-a-ling-a-ling-a-ling-a-ling when the plane has got into the turn sector. With Snipe Raven Albatross, you actually get it at 4 seconds, 8 seconds, 4 seconds, and 2 seconds. So, as I said, start off normally 200, 250 metres and just try and fly along the base leg, listening for the audio and listen for these beeps that tell you when you've got to turn point 1. When you get there, I suggest you actually turn around, come back and practice it again. And just until you're really comfortable just flying this one leg. Once you're happy with the first leg, then try and fly to the second leg. Practice round turn 1 and up to turn point 2. And I know it sounds really, really simple, but I strongly advise you just break it down into individual pieces and slowly build up to flying the whole course. If you just try and fly the whole course in the first go, if you make a bit of a mess of turn point 1, then you'll have no idea where you're going to turn point 2, and it will just get worse and worse and worse until you get frustrated. Trust me, I've been there.
And also, you're concentrating on lots of things too, aren't you? You're concentrating on flying the glider and the course information. So it is a lot to take in, isn't it, John?
So much so, John, that in the first couple of training courses I ever ran in the UK, on the first 2 of them, a glider was actually lost with an experienced pilot because he was so busy concentrating on the information that he forgot to fly the plane.
Oh, okay. That's no good.
So don't underestimate how much is coming in and how much, if you're not careful, you'll get sort of work overload. So breaking it down into individual pieces is important. Okay. I've noticed Mike O'Reilly made has just put a comment up, which is logic at the time. The red arrow, Mike, is the direction of flight. Wind direction isn't taken into account necessarily. The course is generally set out to suit the flying site, and the wind is whichever way the wind is. So it could be any direction across the course. It isn't laid out aligned with the wind. Okie doke. So, having flown round turn point 1 and then slowly work your way to turn point 2, which is exactly the same in terms of how you can come in and out across any of the lines, edges of the green area. Turn point 3 and then back to the start. From 250 metres, or 250 metres, on a reasonable day, you should just about be able to make it round the course. If you think you're dropping short, then start the motor, climb up and go again, and just fly a little bit higher. But don't try and fly too high when you're starting to learn your way around the course. Now, the big things that tend to happen when you're flying around the course is overcorrection. So you're flying along and you hear 20 outside and everything's good. Then all of a sudden you hear 40 outside. So you turn left. And generally you overshoot. So you'll hear 20 outside, 0 outside, 20 inside. So you turn right and you overcorrect again. And you'll end up weaving along the line. Very, very easy to do that. The corrections that you need are very, very minimal. So normally, in reasonable air conditions, certainly with the sport class and scale class, about 100 metres in height is enough to fly one lap if you fly accurately. The reason I'm suggesting you go to 200 is in the early stages, you won't fly very accurately, and therefore you'll fly a lot further. And of course, every time you operate the controls of a model, you're effectively putting the brakes on, so you're reducing the glide. Once you've flown the course a couple of times, but only after you've flown a whole lap, the flights are recorded on your kit. And using something like gpstriangle.net, you can load the flights up, and then you can actually graphically see the track of your flight. And it's quite advisable to do this. One, to learn that loading flights up on gpstriangle.net is a good thing anyway, because that's where we all sort of nominally compete with each other if we're not in head-to-head competition. But also you can see the accuracy of your flying and where you're making mistakes. So I strongly recommend to you that you do upload your flights. It might only be one flight. It might look terrible, but you're the only one who's going to see it, but you'll definitely learn something from it. And taking on board Mike's comment about wind direction, obviously as you fly around the course, you're going to fly in every wind direction relative to the model. So at some point you're going to get being blown off the course. Other places you're going to be blown into the course. And learning to make corrections for the wind so you can actually fly a straight line between the turn sectors without being pushed around by the wind is something that's quite important to learn to fly. So you can see even at this stage, there's an awful lot going on. And I do say strongly advise you to try and break it down into individual little elements before you dive in and try and fly the whole course. The other thing you've got to think about with the wind is rounding the turn points or crossing into the sectors. If you've got the wind on the tail, your ground speed's going to be higher. Therefore, you need to think about starting your turn a little bit earlier. If the wind's on the nose, starting the turn a little bit later because you're going to get blown back onto the turn point. And if the wind's on the side, be careful that you don't start flying what I call kidney shape legs. You get blown in to the course. So you end up getting further and further inside the optimum line, the blue line that you can see on the screen, and then end up having to make a sharp turn at the end to get back out to the turn sector. This will all show up quite well once you load your flights up. So it's worthwhile making a note of where the wind direction was relative to the course on each day you fly, so you can then look at the track on gpstriangle.net and see the effect of the wind and learn how to make compensation for it. The other thing to remember is the higher you fly, the more different the course looks. When you're up really high, the turn points actually look quite close. When you're scratching around the last lap with less than 100 meters on the clock, each turn point looks an awful long way away.
Each leg
So
could be a
again,
kilometre just about when you're scratching, that's for sure. If you're trying to get that last lap and you've got a couple minutes to go.
yeah, it really does. At low level, these turn points do look an awful long way away. So again, it's something you need to learn, but listen to the information that's coming from you, from the kit, because it will tell you how far to the turn point. Bear in mind, you've also got a screen you can check. Although in the early stages, I don't really promote people taking their eyes off the model and looking at the screen, especially if you're flying at low level.
John, should we just see if Dave's got any questions?
Okay.
Dave, have you got any questions for us?
No, not yet, although I've got one myself, if I might, John.
Yeah.
And you're probably still coming to this point, but maybe a discussion as you go along about the balance between climbing and thermals versus getting on with the task.
Yes, well, you'll actually notice I haven't mentioned thermaling at all yet. My personal view is that you need to be able to learn to fly the course before you start worrying about thermals and climbing and flying more laps. Get your groundwork done first. Learn to fly the course, learn to understand what your model looks like as it goes around the course at different altitudes, and where the turn points are. Now, I was just coming on to where the turn points are. If you're lucky enough to have some features on the horizon, then use those as a reference so you've got an idea of where the turn points are. That particularly helps for turn point 3 and turn point 1 because you're looking along the line of the triangle. With turn point 2, the reference is slightly less useful because it's difficult to tell if you're inside or outside the turn point. But if you can use any references at all on the horizon to give you an idea where the turn points are, that's something that will help you very much. There's a question here from Matt. Is sector turn point 3 to 1 directly overhead the launch position? It depends how the course is set out, Matt. It's fairly overhead, especially if you're flying at the start at 400 or 500 meters, because the angular difference, even if it was offset by 50 meters or so, isn't very much. So yes, it is pretty much overhead. Righty, the course looks different at different altitudes. I've talked about overcorrection. Overcorrection is really much more of a problem when the wind is strong and you're getting blown into the course or blown out of the course. So this brings me to the next section of tactically flying around the course. The weather conditions play quite a big part in flying GPS. The wind is obviously going to have quite a big effect. And the simplest way to give you an example of that is if the wind is blowing from turn 3 to turn 1, so it's on your tail as you fly down the long leg, you're going to cover the distance fairly quickly with minimal height loss. If the wind is the other way round and it's blowing from sector 1, turn 1 to turn 3, It's a long leg flying into wind. Now, for the SLS and third scale class, that length is 1 kilometre. For the sport class, it's 700 metres, and for the light class, it's 400 metres. So that's a long, long flight into wind. And of course, there's a lot of time to get blown off course as well. So again, if the wind is up or down either of the other legs or across the legs, you can see it will make quite a difference effect in how the plane is gliding relative to the course. Now, you notice I said relative to the course. It won't affect how the plane is gliding through the air. It's only the air mass relative to the course. But it's something, again, that needs to be learned. Do you just let the plane float around in its normal trim? Or are there times to actually get into thermal mode and get blown downwind? Or is there times where you actually need to get into speed mode or lean on the stick to make way across the ground at all? These are all things that need to be learnt with experience and be comfortable in flying the model.
I've found, John, that probably the biggest thing to get used to is the long leg, is because you're standing in that pilot's box there, which actually in this diagram looks quite a distance away. You're actually a lot closer to that line than you think, and usually you're flying over your head, and you tend to fly, because of the restrictions, I don't know whether it's because I'm getting older, the restrictions in your neck, you tend to fly an arc inwards of the course rather than a straight line, which I find is the hardest thing to do, is to actually fly that line straight.
Yeah, that's very much so, which is why I suggested, again, you load the flights up onto gpstriangle.net, because then you will see if you're flying this bowed leg. It's very easy to do it, because to look directly above your head, or even a few degrees off directly above your head, is actually quite different. I have a particular technique I use when I'm flying from turn 3 to turn 1, and that is, as I come round turn 3, I fly directly at myself, and I'm lifting my head up and up and up and up until actually I can't lift my head up any further. At that point, I turn round, I align myself with turn point 1. I'm listening to the audio to know that the plane's flying in a straight line, and I've got my head tipped back as far as I can until I catch sight of the plane again, and then carry on to turn point 1. But my feet are already facing turn point 1, so I know basically which direction I've got to fly in. That's the way I do it. Other people have different techniques, but really, in this early stages of practicing, you've got to find out what works best for you. But yeah, if you try and keep your head at a normal angle whilst you're flying from 3 to 1, you'll end up flying a great big bow in that line, which of course is more distance, therefore more height loss. Therefore, you're not going to fly as far or as many laps. So, talking about the weather conditions, wind has a big effect on the course. So I was just looking at the message. Andre's posted up a link to GPS Triangle, the league.
Oh, well, yeah, I put that up on the Australian GPS soaring site on Facebook. So I put that up there last week. So, and I can put those links. I'll put those links up again.
Lovely. A Google search of GPS Triangle League. I'm just writing GPS Triangle League. Google will actually find it. You do have to register for it. There's no charges or anything else, but do please get yourself involved in the league, because it really will help in the early stages of training.
Yeah, you just have to create an account. That's all. So
that's it. Yeah.
Yeah. So, are there any questions, Dave?
Yep. One more question from David Woods. At what point should you add ballast to your model?
Oh, that's a very good question, Dave. In simple terms, if you're not moving up the course fast enough, how much ballast and how it affects your model varies very much from model to model. Fundamentally, if it's a good day and you're looking for a high number of laps, then you always tend to fly ballasted. The thing about ballast is, excuse me, the more ballast you've got, the faster your plane's coming down. Therefore, you need to find lift more regularly to go up or stay up to be able to fly further distances. So you'll cover the ground quicker, but you'll be coming down quicker. In the early stages of training, my strong advice is don't use ballast at all. Keep the plane as light as possible, as easy to fly as possible, because to a certain extent, the slower it's flying, the more time you've got to concentrate on all this information. If it's tearing around the course at breakneck speed, it's very easy for it all to get wrong a bit quick, and then things can get a bit unpleasant and you need glue. And through these learning stages, the key thing we want to do is keep the plane intact, so you can keep practicing and keep you motivated to carry on. So yeah, on a day when you're looking for big laps, ballast, or if the wind is really strong and you need it for penetration. But it very, very much depends on the conditions and the models that you, type of model you fly.
Yeah, well, it comes a lot into the trimming of the model, doesn't it? So that's really a thing that you do before you start flying GPS is experiment with different wing loadings and your trim. And we'll talk more about that probably in the next session in a couple of weeks' time, I think. Yeah, we'll go more in depth in that. Yeah.
Yeah, not all models suitable for flying with GPS even take ballast. And during the learning stages, it really doesn't matter what sort of model you fly. It doesn't need to match any particular class distinction. Even a big foamy could be enough to learn how to fly the course, listen to the audio and understand what it's all meaning. You don't need, a super duper hot shit GPS model to learn to fly the course. And in many respects, a super slippery, fast ship is probably not the best thing to use to learn. So key thing, as I said right at the beginning, is whilst listening to all of this information and trying to understand what it all means, you've still got to be able to fly the plane. So something that you're confident flying, something that's easy to fly, you'll learn much faster than some very expensive, slippery, hot shit that you're a bit worried about. And you're spending all of your time concentrating on the plane and not on the information that's being provided.
Yeah, I think Early told me a story once where they have a Challenge Cup in Spain every October, and they had very marginal weather one year, and a guy was there with just an average foam core scale glider, and he won the event because the weather just suited that model. So you don't have to spend necessarily big bucks and have a rocket ship to do this.
That's very, very true, John. My personal view is that the ultimate GPS plane has yet to be built at any price, simply because we fly around the world in such varying weather conditions that the optimal model for GPS flying is the one that does okay in the widest range of conditions. Now, it's easy to design a plane that will be absolutely perfect in one set of given weather conditions, but even in the course of the flight, which can be 20 minutes or half an hour, the weather conditions can change quite considerably. If you're not out on the plains of Spain, certainly in the UK, and I've witnessed it in Australia as well, you can get quite wide weather conditions in a short period of time. So the ability to fly whatever you're flying accurately, understand the information that's coming to you and how to use it, is far more important than having the supposedly the best hot ship this week's winner model. Many competitions have been won by what I would consider to be, average models that are flown well. An average model with a good pilot will almost certainly, 99 times out of 100, beat a hot ship flown by an average pilot. And that's the beauty of GPS flying. It's really is about pilot and pilot ability and less about actually how good the plane is.
But also the average pilot. Sorry, I interrupt. The average pilot can be not necessarily average skills, but could just be that he hasn't taken the time into setting the model up and or practicing flying the course, and that's a big one too, isn't it? So
it very much so. I mean, if your plane won't naturally fly in a straight line at a stable pitch in the glide, then you're making life very difficult for you. So having a properly set up aeroplane that will actually go where you point it, turn when you want it to, and glide basically hands off. If it won't do that, then you're really on a hiding to nothing. Setting up the plane, trimming a plane properly is important, but I'm assuming at this stage that you've got a plane that you're reasonably happy with how it flies. So we can talk in further chats about the detail of trimming and setting up and whatever. But for this learning stage, it's so important in my mind to have something that's simple to fly so you can concentrate on all the information and what you're trying to do with the plane rather than actually flying the plane itself. So a little bit more about the starting. Once you're happy that you can find your way around the course, then it's time to start working up higher and higher and higher until you're happy flying the plane up at the specified maximum launch height for the class. Now, the start can be really important in terms of flying big numbers of laps. And hopefully I'm going to be able to explain this. And we'll take the sport class as an example, although it's exactly the same for all of them. The sport class has a maximum start height of 400 meters and a maximum speed of 120 kilometers an hour. Thank you, John. So if it's logical that if you cross the start line at 300 meters, then you're not going to glide as far as you would if you're at 400 meters. But what most people forget is the speed element is also quite crucial. Now, the average sport class glider will probably have a still air glide speed of around about 50 to 60 kilometers an hour. I'm not talking about ballasted or highly polished hot ships here, but your normal glide is going to be around about 50, 60 kilometers an hour. So if you can cross the line close to 120 kilometers an hour, you've got quite a bit of excess energy in the aeroplane. So in the ideal world, if you cross the line at 399 meters, flying at 119 kilometers an hour, as soon as you cross the line, you could pull back on the elevator, zoom up, and then as you're approaching your normal glide speed, bunt over, and therefore just a couple of seconds after crossing the start line, you could be at 430, 440, even maybe 450 meters. Now, conversely, if you come bimbling up to the line, trying to stay as high as you can by flying too slowly, and let's say you cross the line at 375 meters, but you're only mushing to the stall at maybe 40 kilometers an hour. Yes, okay, the start will start in the normal way, but now to get going, you're going to have to push them down in, get up to your glide speed. So by the time you've done that, a couple of seconds after the launch, you're probably going to be close to 350 meters. Now you realise the guy who crossed the line at 399 doing 120 is already 100 meters higher than you are. Take a moment about that. You're only a couple of seconds into the course and already the guy's 100 meters higher than you are simply because he made a better start. Now, 100 meters height, that's 25% more in terms of the gliding around the course. Therefore, in theory, he's going to go 25% further than you are. So practicing the start is crucial. There is some information available to you via the GPS kit as to your height. There's also screens that you can set up in Albatross that will help you with height. But fundamentally, it's all about practice. And many people have their own ways of how to cross the start line. My personal way I tend to do it under most conditions is I will climb up to about 450 meters. Climb up to 450 meters. Sorry, I'm just looking at my notes. There's something else I've missed out here. But I'll climb up to sort of 450 meters, somewhere out halfway between turn point 2 and where I'm standing. And downwind or downrange of the start line. I will then fly along the start line, probably about 50, 75 meters out from the start line, watching my height decay. You can see that on the display, until I'm down around about 420 meters. At 420, I check the speed, make corrections for the speed if needs be, and as I see about 410 on the altimeter, I'll then turn into the course. Now, with practice, you can do that pretty much on the baseline, but that way, I've got time to make adjustments before I cross the line. If you're flying straight at the line, for example, from turn 3 straight up to across the line towards turn point 1, you've got very little scope for making adjustments to your height or speed because you've got no room. You're flying straight at the line. So again, work out what suits you. Think about what you're trying to do. Now, the other thing that's important is where the wind is relative to the start line and turn point 1, because this can also give you some additional benefit. Now, if the wind is blowing from turn point 2, looking at the example that's on the screen, then you're better off crossing the start-finish line inside the triangle. The reason for that is if you cross 20, 30, 40 meters inside the triangle, your track down to turn point 1 is slightly downwind. So you've got a wind effect that's helping you. If you've overshot the baseline and you're away downwind of the baseline when you cross it, your flight towards turn point 1 is going slightly into the wind, which of course will be less effective. So again, if you factor in the wind direction plus your speed and altitude, you can see that by the time you get to turn point 1, a good start and a bad start can make an enormous difference in the height that you've got. John, you want to jump in here with any of this?
No, I think it's going well.
Okie dokie.
Yeah. Have you got any questions, Dave?
No new ones at this point, thank you.
Okay, yep.
Thank you, Dave. Right, carrying on then. With the light class, the sport class and SLS, you're flying yourself up to launch height. The third scale class, you're actually towed up. So what I'm going to talk about now doesn't apply so much to the third scale class, although there is something you learn from it. Many people I've seen starting with GPS flying seem to be in a rush to get to the start line. This, in my view, unless the clock is running down and you're in competition and you've actually launched late and you're running out of time, there is no real benefits at all in ridiculously high climb rates flying up to the start. What I tend to do is fly at a reasonable climb rate such that I can assess the air. I always tend to climb up, if the site allows it, upwind of the start line so I can read the air that's coming. There's no point in doing this flying downwind. That air's gone. So it's good air. You can't really use it anyway. It's gone. But by flying accurately with a properly trimmed plane under power, and if you know your normal climb rate, which again is available via the GPS data that's coming back to you. My GPS special that I normally fly, it climbs around about 5 to 6 meters a second. And I've got it trimmed to do that hands off. And using the integral vario, which is part of the data that's available to you via your GPS, if I'm climbing faster than that, then I know I'm in good air. If I'm climbing slower than that, I know I'm in bad air. So by climbing up, keeping an eye on what your integral vario is doing, and flying upwind of the start, you get a good idea of the state of the air. Now, unless you're running against the clock and you've got to make a start because you're running out of time, the time window's closing, if you're in bad air, there's really not a lot of point in starting to fly around the course. If you're in good air, you can actually mark where it is, track back to the start line, score the start, and go back to that good air and use it, depending where it is drifting across the course. So again, there's an awful lot that can be learned at the early stages, even before you've crossed the start line, to know what the air is going to be like. I can remember one occasion when I actually thought I had a problem with my motor. The climb was so bad. I was climbing about 2.5 meters a second. And it took me a bit of a while to work out that actually it wasn't a problem with the model at all. The air was terrible. But I still watched several people rush to the start and go through the start line. And they were on the ground in a lap and a half. I elected to fly out of that, turned the motor off, just glided round upwind, waiting for that horrible sink to disappear, marked when the next bit of lift was coming, back through to the start line, made the start, got the lift, and I think actually I flew 9 laps. Yet 5 or 6 minutes earlier, these people had made a jump, flown into sync because they weren't reading the air. So another important thing that you can learn about how to make the start.
You do have to be a little bit careful. Like, it's fine if you're in a small group, but you do have to be a little bit careful flying downwind. If you're in a competition with a heap of people coming at the start line, they get a bit disgruntled if you're flying backwards around the course to go back to your lift.
Yes, the more people that are flying, I'm generally talking, John, here about the sort of the learning phases.
Yeah, I understand
in
that.
competition, of course, there can be up to a dozen planes all jockeying for the start inside a start window. And there's some fairly specific rules that have now been put in place to ensure we don't have mid-air collisions, etc., etc. But I think that's something we can talk about further down the line.
Yep.
I'm much more trying to cover at the moment the basics of flying and giving an understanding of how what seem like fairly minor points can make quite a big difference. This start height and speed, you realise it makes an enormous difference. So it's worth practicing that. The other thing that I've always found wherever I've flown is, and I tend to use it, whoever that is, somebody's got their microphone on.
I've just muted him, so it's all right. Yeah.
All right, thank you for that. I use an old adage, get high, stay high. And what I mean by that is, whatever your maximum start height is on the course, if you can find lift at that height, it will be stronger than it will be at a lower level. So in the early stages of flying around the course, if you find lift, use it. The higher you are, the earlier I would say grab a bit of lift and use it. Especially if you're in the early stages of learning, half an hour or 20 minutes if you're flying in the light class is an enormous length of time, and you're actually unlikely to fly out half an hour. So there's plenty of time to find lift and use it. Many people I've seen get too focused on flying laps, and they'll fly through lift when they're at high level just to get another lap in, and then at lower level they're scratching around trying to find lift, which of course at lower levels is never as strong. Therefore, if it is good enough to climb in, your climb is going to be much slower. So I always like to do the get high, stay high. I'm looking for any lift at all when I'm up high on the course, even if it's quite weak, because if it's weak when you're up high, it's going to be almost non-existent when you're at low level. So if you can get high and stay high, the thermals are stronger, which means you've got more chance of climbing or more chance of flying fast. And again, unless you know that the conditions are really booming and you're going to fly out for half an hour, the important thing to remember is the person with the most number of laps wins. So if you do 4 laps in 25 minutes and a guy does 3 laps in 10 minutes, you win. The only time that it becomes important from a time perspective is if you're both on the same number of laps, the one who did it quicker wins. Okay? So, the number of laps that you're going to fly on any given day is totally dependent on the conditions and how well you fly. So, I think in the years I've been flying GPS, I've probably flown thousands and thousands and thousands of laps. And I reckon the number of times I've flown out half an hour is in the hundreds. So just take that in for a minute, that time isn't really the driving force. So don't be in a state of rushing to get a lap. Spend time thinking about.
As John, looks like John's cut out there. What I'd add to that is usually if you've got average to good weather, the time usually goes very quickly. It's only when you're trying to do it in poor weather that the time goes quite slow. So, Dave, have we lost? Oh, there we go. I think we've lost Dave. We've lost John there, Dave.
Yeah, I think so. Just he's probably got England slow down on the internet for a moment.
Okay.
There's just side discussion there. The question from David whether the Facebook Live session on Sunday afternoon or evening in Europe and Monday morning in Australia and New Zealand is going to be in English or German. That's in English, and I've just put a link to those of you not aware of that. There's a Facebook page, GPS Triangle League, where the link to that briefing from Philip and Philip Kolb, Daniel Aberley, will be hosted. Should be another informative session.
Yeah, you've got your 2 multiple world champions there. So, Philip Kolb has won just about everything there is to do with RC gliding in the world, and he's really he's won. Been the world champion for GPS several times, and Daniel is the current world champion. Also owns a business that manufactures some absolute magnificent composite aircraft. So I'm sure it'll be a really interesting time to listen to. So I think, and hopefully they're recording it, because for us here in Australia it's about 4:30 a.m. So.
Yeah. John.
Sorry, John.
John's back.
Sorry, John, you cut out there.
I did. The screen went completely blank dead, and I've had to reconnect, so apologies.
Oh, okay. That's all right.
But while I was doing that, I did do a quick check on the time, and I think we possibly covered enough
for the day
this time round in terms of the basics. I mentioned quite a lot. There's a lot in there to absorb.
No, thanks a lot for that, John. That was really good, really informative, and we'll probably continue on with that. We'll talk about, I think next time we'll talk about perhaps glider trimming, and you can continue on with flying the course. Okay, is that
okay?
Yep. So, Dave, have you got any other questions for John or John?
Thanks, John. This one might even be a good question for Andre. Positioning of the aerial of the Sparrow in an F5J airframe. As most F5J designs have carbon-only fuselages, so they're not 2.4 friendly, dangling the aerial out of a hole in the bottom of the fuselage seems to give suitable RF, but the aerial is vulnerable to being pulled off. Andre, would you like to comment on that?
Yeah, hi. Well, if it's a carbon fuselage, then it's a no-go. You have to drill a hole. I would drill it on the side, not on the bottom, as if you land, the aerial will just be pushed up and drifted along. If you cut it on the bottom, it may be cut off when you land.
Thanks, Andre. And another
And
issue
what I
found.
would do, what I would also do is to, when you cut the hole in the carbon, put some shrinking tube over the aerial on this area so it's protected more, so it's not easily cut, so it's a bit stronger on that side.
Also, in addition to that, Andre, is it necessary to have no carbon over the Sparrow?
Yeah, that's for sure, because
Yeah, so
if you have a carbon over the Sparrow, the GPS antenna inside the Sparrow will not get any satellite, so there's no GPS.
Yeah, so I have talked to a few guys about that with existing full carbon models, even if the canopy's carbon, and it's suggested that maybe they'd have to either get from the manufacturer a fiberglass canopy or lay a fiberglass canopy up and have the Sparrow under that. So the Sparrow can't be covered by carbon either.
John, I with my Plus X have just 3D printed a plastic canopy.
Of course you have.
which
of course everybody can do. Yeah.
Of course. Now that you mention it, I could sell those. But anyway, that has proved to be quite a good solution to a thin carbon canopy just stops everything, but a plastic one, it's it all through. It works fine.
So has it got a lump in it, Dave, for the Sparrow, or?
No, I have a Flymate, but that's
okay, yeah.
But at the moment, all I've done is Joe, in fact, gave me the 3D model for the Plus X canopy, which is the same as a Supra and a few other airplanes.
Yeah, okay.
And so now I'm going to build a bracket into the bottom of it, which will hold the Flymate. The Sparrow would be the same up against the bottom of the canopy to give it even better visibility.
Okay.
Yeah.
Yep. Okay. All right. One point
on that. Given the relatively slow flying speed of the light class models, I've actually seen a situation where the aerial was mounted vertically up in a piece of small diameter plastic tubing, and it stuck out of the top. So completely non-vulnerable, and the amount of air drag that would create in terms of glide performance is zero. And that was a very effective thing. That had superb signal, no signal loss at all.
Oh, okay. Okay, yeah.
Rather than having it just sort of dangling, almost standing up, a bit like a tech probe.
Yeah. Another couple of questions I had during the week was one about sports class and ballast. And basically the sports class rules, you can ballast it up as much as you like, as long as it doesn't exceed the all-up weight of 7 kilos. Because with sports class, you're limited to 5 meters and 7 kg. That's correct, isn't it, John?
And also wing loading, 75 grams per square decimeter.
Oh, okay.
So for a small model, you might not get to 7 kilos.
Right. So is there a listing of that in the rules? Is there?
Yes.
Okay. All right. Yep.
There's a maximum wing loading, as well as a maximum. You've got maximum span 5 meters, maximum weight 7 kilos, but maximum wing loading 75 grams per square decimeter.
Yeah. Okay. All right. Yep. Thank you. And another question was: are telemetry controls legal in GPS flying? And I had a look up, and Rule 2.7 states that no autopilots or gyros are allowed. So the pilot has to be in full control of the model. Okay, that's all the questions I've got. Dave, have you got any more?
Perhaps a question for Andre, I don't know. If there's a competition where there are multiple snipes and Sparrow Ravens together, are there any interference issues?
Normally, each of the system, plane, ground unit have its own channel for now, but I just plan to release new update maybe today or Monday latest with frequency hopping enabled, and then it should be no problem. We tested this early in March in Germany, 13 pilots flying together, frequency hopping, no issues.
Thanks, Andre.
Okay, well, thank you. If there's no other questions there, Dave?
Just one from John Minchell about the GPS meeting on Sunday, and it's at 20:30 CET, which I suspect is an hour ahead of the UK. Would that be right, John?
I think that's the case, but a quick Google of
The time
zones
zone,
will help you out on that one.
Yeah. Because when I advertise these, when I advertise these Zoom sessions, that everyone's questioning the times that I put up. So it's quite easy just to Google that, like I do for looking at times around the world. So I'll put a link on the Australian GPS Facebook page for that Facebook session also. Okay.
Cool. John and John, on behalf of everybody, thanks very much. It's cool to see the guys from as far away as the UK, Finland, around New Zealand, around Australia, and I'm sorry if I don't know where a few other guys live. But wonderful, great session. Thank you. I learned a lot, and I've made some notes, and particularly the little gem I picked up was starting the start line at 90 degrees. Yep. Coming into the start line in a line between 3 and 1 was always a bloody challenge to get the speed and altitude right, but now I've got this little secret that's really cool.
Yep.
So thanks, guys, and looking forward to the next one.
John's good at giving away those little secrets.
Yeah.
Thanks a lot, John, for your input. It's really good. So hopefully, all going well. We'll see you in another fortnight. And thanks for your time. And we'll see you later.
Thanks, John.
No worries.
Yep.
If anybody wants to contact me with a question outside of this, then you can find me on Facebook. You can do it via Messenger. That'll probably get to me. So feel free, if you've got another question or you think of something in watching the review and you want to clarify something, then please feel free to get in touch.
Yep. Thanks, John. And also, I'll just add that if anyone in Australia if they've purchased gear and they need a hand in setting it up, they feel free to contact me. If I get a few people, I might set up a separate Zoom session for that. But we're here to help to try and get people into this fantastic side of the sport.